Hello everyone, welcome to my channel SGKM Education. In our previous classes, we have discussed about the important questions already came in previous year's exam in JEE Mains and Advanced level on based on the topic of spin only magnetic moment or magnetism. In last session, we also discussed about the spectrochemical series, how to know easily what is weak field and what is strong field ligands. Because without knowing strong field and weak field ligands, you cannot easily get the value of spin only magnetic moment, and you cannot do the structure with the help of the VBT and CFT, that is crystal field theory, and VBT means valence bond theory. So today we shall discuss the important questions on the same topic, spin only magnetic moment, that already we discussed in last sessions. These two questions are various type of questions from last session we discussed. So the first question is the correct order of spin only magnetic moments for the following complex ions. So there are four type of metal. One is iron, two is manganese, three cobalt, and four is manganese. So three types of metal: iron, manganese, and cobalt. You have to correct. You have to uh, answer the correct order on basis of the spin only magnetic moment. Now see, if you know which one is the strong field and which one is the weak field ligand, you can easily get the number of unpaired electron with the help of VBT or CFT. And number of unpaired electron more means magnetic moment value also more, because we already discussed the formula of spin only magnetic moment, that is mu equal to root over of n into n plus 2 Bohr magneton. So n value is more means mu value is more. So in this type of question, we have to we have to calculate the number of unpaired electrons. That is the important thing. Number of unpaired electrons. So if you get more unpaired electrons, that is the more spin only magnetic moment value. Okay. So first we will see FeCN6 3 minus. Now see, already we discussed in our last class, Cn is the strong field ligand, because carbon is the donor atom. Carbon and nitrogen donor atoms ligands are all strong field ligand. Now iron is 26. 26 means argon 3d 4s 2 3d 6, right? 3d 6, because argon is 18 electron. So 26, 18 plus 6, 24 to 26. Now here you have to first calculate the oxidation state of iron. So Cn is basically Cn minus, each Cn minus means 6 minus 6 of Cn minus 6 minus, so it is plus 3. Minus 6 plus 3 means 3 minus. Okay. So overall charge is 3 minus. So iron in plus 3 oxidation state, Fe3 plus. So Fe3 plus means you have to remove electrons from outermost shell. Already from 4s, 2 electron will be removed and 1 electron from 3d. So 3d 5 is here. Now in case of strong field, according to VBT, you know there are 5 d orbitals. So 1, 2, 3, 4, 5. So according to VBT, what you have to do? You have to do the pair, because Cn minus is strong field ligand, and what it will do? It will do the inner d orbital complex, that we already discussed in last classes. Inner d orbital complex. So inner d orbital complex means that these two d orbitals will be bonded with Cn minus ligand. So there is only one unpaired electron in Fe6 3 minus, only one unpaired electron. In case of VBT, you can see only one unpaired electron. In case of CFT, according to CFT, T2G and EG level, so electron will fill up in T2G level 1, 2, 3, 4, 5. So here also you can just cross check according to VBT and CFT, both are having on unpaired electron. Both will same. Just I am showing you the both concept VBT and CFT. So only one unpaired electron in case of Fe6 3 minus. Now we will check the next coordination complex. MnCN 6 3 minus. So manganese you know 25, 25 means argon 3D 4s2, 4s2, so 18 plus 223. Okay, so 3d3. Now that is minus 6 plus 3. So manganese 3 plus means argon 3d2. So 3d2. Now, oh, sorry, here 18 plus 2 20, 20, 25. Sorry. So 3d4. Okay. So 3d4. So 3d4 system. Now according to VBT, first you will check CN is the same strong field ligand, so it will do inner d orbital complex. So 2 d orbital we have to leave because of CN minus coordination complex. So 1, 2, 3, 4. 1, 2, 3, 4. So there are two unpaired electrons. Two unpaired electrons. In case of CFT, you check T2G and EG. So how it will fill? 1, 2, 3, 4. So there are also two unpaired electrons. So number of unpaired electron in case of FEC 6 minus we get 1, and in case of MnCN 6 2 minus we are getting 2. Now in case of COF6 3 minus we will see. COF6 3 minus. So F is weak field ligand. Obviously it will do outer d orbital complex. So no pairing up of electrons. Okay. So first you find out the oxygen state of cobalt minus 6, that is plus 3. Cobalt is 27, that is argon 3d 4s 18 plus 2 20, 7 electron 27. Now cobalt 3 plus means argon 3d 6. So in case of VBT 1 2 3 4 5 6, no need of pairing out because this is weak field ligand. All the bond will form in outer d orbital complex, outer 3d orbital complex. Okay, so no need of pairing. And in case of CFT also you can cross check T2G EG. So electron will fill like this way: 1 2 3 4 5 6. So there are 4 unpaired electron in both cases. Here also 4, here also 4. You can do any one. Just I am showing you both the theory, CFT and VBT. So we are getting 4 unpaired electron in case of COF6 3 minus. Now in case of MnBr4 minus, MnBr4 2 minus. So that is tetrahedral complex because Br4 not 6. So minus 4 plus 2, manganese is 25, again Ar 3d5 4s2. So manganese 2 plus means Ar 3d5 only, and it will form obviously high spin complex because that is weak field ligand. So outer d orbital complex, no need of pairing, same case. So in case of VBT 1 2 3 4 5, 5 unpaired electrons. In case of CFT also you can check. This is tetrahedral, so the scenario is different. In case of tetrahedral complex, T2 level and E level. E level in ground state and excited state is T2 level. Okay. So lower energy level is E and T2 is the higher energy level. So 1, 2, 3, 4, 5. So so 5 unpaired electron in both cases. So here we are getting 5. So no need to check the other options because first option itself is the correct option. 5 greater than 4 greater than 2 greater than 1. Okay. Next question. Next question came in JEE Advanced 2017. For the octahedral complexes of Fe3 plus in SCN minus thiocyanate, that is sulfur coordinated, and Cn minus. So this is thiocyanate, and this is cyanide, Cn minus. So Cn minus, coordination is with carbon atom, and in case thiocyanate, sulfur atom. So the difference between the spin only magnetic moment you have to find out in Bohr magneton is nearest integer, and atomic number of iron is 26. So first Ap3 plus already given. So Ap3 plus when it will be possible if the complex is ApSCN6 3 minus, then only you can say it is Ap3 plus. In case of Cn minus also ApCN6 3 minus. Okay. So SCN minus is the weak field ligand, while Cn minus is the strong field ligand. Okay. So strong field ligand, obviously it will do inner orbital and low spin complex. Inner orbital complex in VVT and low spin complex concept in CFT. Okay. Now this is weak field. So outer d orbital, it will form outer d orbital complex and high spin. Okay. According to VVT, outer d orbital, according to CFT, high spin complex. Now what we will find out? The so both are D5 system, because Fe26 means already we have discussed air 3D 6 4s2. So Fe3 plus in both cases is air 3D 5. So both cases, that is D5 system. Now we'll check T2G EG, T2G EG. So 1 2 3 4 5, and in case of high spin complex, how the electron will be filled up? 1 2 3 4 5. Okay. So here you can see only one unpaired electron. Okay. And there you can see 5 unpaired electrons. Okay. Now you calculate the mu value, spin only magnetic moment value in both cases, root over of n into n plus 2 bm, mu equal to root over of, here you can see 4 into 4 plus 2 bm, root over of 24 Bohr magneton, so almost 4.92 Bohr magneton. And in case of uh, high spin complex, 1 into 1 plus 2 Bohr magneton, so root over of 3 Bohr magneton, so this is the 1.73 Bohr magneton. So now you can differentiate the value 4.92 minus 1.73, or if you uh, take the integer value, then if you just, you can put the value 1.72 in place of 1.73, so 3.2. Different is almost 3.2 Bohr magneton. So this is the answer. The approximated to nearest integer is 3.2 or you can write directly 3 Bohr magnet. Okay, so this is the very important question, and the different type of important questions I already covered in these 3 episodes. Hope it will help you a lot. If you want to know, if you want to watch more videos, if you like my videos, then please subscribe my channel and do like if you like this video, and do comments also if any query. Please subscribe my channel. Unless you will not get any notification, please press the bell icon to get the notifications. Thank you for watching.